All right, good morning, everyone, and welcome to our 10:15 panel discussion on building out the ATSC 3 station. My name is Dennis Wallace. I'm the managing partner of consulting engineering firm Meintel, Sgrignoli, and Wallace, and I'd like to thank you very much for attending with us this morning. As many of you know, there was a big announcement in this space yesterday morning about ATSC 3 transition markets that will be rolling out over the next year to 18 months in various cities across the United States, and stations getting together to collaboratively transition their markets with ATSC 1 hosts and ATSC 3 hosts. Part of that transition obviously involves modifying the transmission facility to accommodate ATSC 3 transmission. So our panel this morning is going to be focused specifically on what do we need to think about in terms of the ATSC 3 transmission plant. And we have with us four very well qualified and esteemed panelists that all are from the transmission side of the broadcast business, and I'm going to introduce them to you. But what we've asked them to do is answer some questions about specific ATSC 3 transmission considerations, and we'll go through a list of questions that I have, and then we'll open it up to the audience if you guys have some specific questions at the end. To my far right and to your far left is Joe Seccia. Joe is the principal architect of DTV transmission products for GatesAir, and Joe's been involved in digital television for a very long time and has served in the ATSC 3 physical layer standards group along with myself, so he's very familiar with the ATSC 3 standard. To my immediate right is Graziano Casale, and Graziano is Rohde and Schwarz transmitter products, and they also have some ATSC 3 transmitter on the air and are very busy with repack as well. So we'll be hearing from Graziano in just a moment. To my immediate left is Tom Barbeau. Tom is the Vice President of Engineering for Comark Communications, also a transmitter manufacturer and vendor of transmission products, and was involved in the single frequency network deployment in Dallas, as well as ongoing in Phoenix, and some of the Sinclair deployment in Washington, D.C. area. And here in the hall, the SFN that we have here in the North Hall is also a Comark deployment. And then on my far left is Jay Yogeshwar, who is Chief Strategy Officer with Thomson broadcast products. So first, welcome to our panel. Thank you very much for participating. And I'm just going to kind of start off with a question. We'll just go down the line with everyone responding appropriately. So first, what's the first thing that a station should consider, Joe, when they're planning their ATSC 3 transmission transition? Where do you even start? What's the very first step that a station should undertake in considering transitioning to ATSC 3 from a transmitter perspective?
Well, from a transmitter perspective, I think it's take a look at, is the transmitter you have ready for ATSC 3? And there are so many transmitters being replaced in the repack that most of them, from the repack perspective, are new transmitters. We all design transmitters for worldwide standards. Worldwide standards have been on OFDM technology for, well, since their beginning. So they're largely ready for ATSC 3. If you were one of those folks who were not repacked and you have an older transmitter, you need to evaluate how ready that is for an OFDM waveform, power reduction that might come from retrofitting it, and contact that manufacturer on just how suitable that transmitter is for ATSC 3 waveform.
Okay, great. Graziano, same question. What's from your perspective? Is there anything to add to what Joe said? If your station is thinking about moving to ATSC 3, what's kind of the checklist of things that I want to run through, make sure that I'm prepared on the transmission side?
Yeah, I agree with Joe. First and foremost, talk with your transmitter manufacturer, determine the TPO that is needed based on your antenna design. If you're changing antenna because of the repack and you have had some vertical polarization, you might need a larger TPO, so make sure that you got that power cover, and as well, again, talk with the transmitter manufacturer to see if all the other components on the transmitter sides are ready, the filter and the station loads and everything else. So those are the first step.
All right, great. So let's transition to some experience in the field. Tom, I know Comark's had some product deployed in Dallas and other SFNs, and it may be a little early from those early market deployments, but has there been anything in those deployments that's just surprised you, or what's the most important thing you've learned in these early deployments that Comark has been involved in?
Really, there haven't been any technical surprises in the deployments. The biggest problem has been lead times and the rush. So having the ability to get key components like RF systems or antennas or coax, that stuff on site has been really the biggest hurdle in the rollout. Certainly everybody is working full steam and we're able to crank out the transmitters. The biggest problem has really been coordinating to make sure that everything gets on site, gets ordered. Everybody is making adjustments or trying to figure out how much extra power they can get for maybe a future vertical pole. But and the longer they wait, trying to figure out where they think they need to be or waiting on a consultant, the harder it is to get everything on site when they need it to be there.
Right. So just in terms of time frame and scheduling and so forth, sure, understood. So Jay, one of the questions that comes to mind for me and for our clients also is if a station's repacking, they don't really necessarily have an intention to move to 3.0 immediately, but they're going to be buying a new 1.0 transmitter as part of their repack. What are some of the things that they want to maybe think about in terms of looking at an ATSC1 transmitter so that they're prepared for ATSC3?
So if they're looking to repack and go to ATSC1 transmitter, they might as well have it ATSC3 ready because it's going to have a reduction power, so there's going to be a lot of cost savings in going to the new transmitter, and so having that to be ATSC ready saves them a lot of hard work later on. Because everything is different with ATSC3, with the exception of the mask filter, right? So they might as well start to plan for ATSC3 well ahead of time.
Right, understood. Okay, Joe, I know that one of the considerations in the new standard ATSC3 is that this is really using an OFDM technology as opposed to the single carrier VSB system that we've used for years in ATSC1. And there was a lot of consternation early in the standards process about what the implications would be for transmitter manufacturers' peak to average power capabilities and so forth. How do you view the difference in terms of the 6 dB peak to average power number for ATSC1 versus, call it 8 for OFDM? And how does that impact the design? Is there any special consideration that stations would want to take into consideration when moving to OFDM? What's the impact on the entire system? Just kind of give us some insights on what that really means to the station.
Okay, well, the key to any amplifier's linearity is the ability to faithfully reproduce peaks. So from NTSC time or PAL time, we are looking at the peak power. Because that really governs its ability to be a linear transmitter. And if it is nonlinear, as my late colleague Bob Plonk used to say, nonlinear at any speed, it would, that waveform is gonna clip, and that clipping is gonna result in sideband energy. So if the peak power capability of the amplifier is not sufficient, you will never be able to make the radiation mask because there'll be too much sideband energy. So as I said earlier, we've been designing for OFDM waveforms for world markets for a long time now, and we know that it's roughly an 8 dB number, a little bit higher than 8 when it's very linear. But due to adaptive correction circuitry and so forth, we have to precondition the waveform so that we don't destroy amplifiers when trying to do pre-correction, because what they have to do is peak stretch. They have to stretch the peaks so that it comes back and is linear, and if you stretch it too far, you'll destroy silicon. So that's been at the forefront of PA designers' minds for a number of years now. Right. So I think for broadcasters to take away that it is 2 dB as a practical matter at the amplifier output, and the newer models of transmitters, take that into account, and look at any manufacturer's data sheet and see what they state you can get out with an OFDM waveform, ISDB, DVB-T, DVB-T2, and that will be the power you can get out with ATSC3. And rest assured that that we have done our jobs here and got a proper design. On the RF system point of view, it's my understanding that they quite often use a 10 dB peak design headroom, so mask filters, transmission lines, and so forth should be fine. But if you're going to go into a combined situation, it should be checked, because you can get statistical adding of peaks, and it may be very, very low probability, but it's a possibility.
Excellent. All right. Thanks, Joe. So Graziano, one of the things that sometimes people forget is there's about 500 or 600 stations that are not transitioning as part of the repack. They're going to stay on their existing channel with their existing transmission facility. And the question that I often get is, can I convert that existing ATSC1 transmitter to ATSC3, and what are the considerations for doing that? Is that a good idea, a bad idea? Should stations really think, well, if I'm going to move to 3.0, I really should buy a new transmitter? Or is it a situation where if I have a newer, older transmitter, are those modifiable, for example, to do ATSC3?
So, in a short nutshell, the answer is yes. So we have a practical example right here at NAB. The Sinclair mobile truck outside has a Rohde Schwarz transmitter that is an 8000 series, which is probably about 8 to 10 years old, that has been retrofit in a way to broadcast in ATSC 3.0. So it is doable on a theoretical way. On a practical way, there are other factors to consider. First and foremost is, what's your new transmitter power output requirement for ATSC 3.0. So it really comes back to the VPOL antenna you're going to put up there that will change your TPO requirement on the transmitter and the kind of business model you're planning to implement for 3.0. So maybe as a practical scenario, what we see is that many of those transmitters can easily be repurposed as a backup, and a new platform will provide many benefits other than, first and foremost, what you really need for the coverage you intend to reach, but even in terms of newer products being better design, more efficient transmitter, cost saving, and that's one consideration. The second consideration is what kind of approach are you taking down the road if it's the big stick versus the SFN. I know we're going to cover that later, but that will factor into this kind of decision.
Sure. Okay. Well, on that note, let's talk about SFNs for a moment. Tom, I know your company's been involved in some SFN deployments, and broadcasters, I think, are generally thinking about this as what I always term a crawl, walk, run approach, and that is we have to sort of start out with something before we move to the next level, So the corollary to this would be start out with the big stick, operating in ATSC3, and then add some maybe 2 or 3 additional SFN transmitters to build a sparse SFN, and then as needs for capacity grow, go to a denser SFN with maybe 5 or 7 sites or something like that. What are some of the things that broadcasters and station engineers should be thinking about in terms of SFN deployment, and is that crawl, walk, run approach really a good idea, or is there a better approach?
Again, for SFNs, it's all going to come down to the business approach. Which group are you affiliated with? What's your plan? How are you going to make money with it? That's always the big question. So from SFNs, we're seeing and are part of 2 basic approaches to that. One is the big stick, and then the medium power transmitters, which is Dallas and is Pearl. We're also Pearl and Phoenix. We're also talking about other deployments where it's one big stick and hundreds of little night light transmitters, or gap filler type transmitters, 5 to 50 watts. We have one on our booth. I know Gates has one on theirs, and in that case, you're kind of building a broadcast equivalent of a wireless mesh type network. Both are going to be out there. I think that in the beginning, it's going to be the big stick and medium power, 5 kilowatts, 500 watts, somewhere in those range strategically around the DMA. I think that is probably going to be the most common way to start. I don't think that's the way it's going to finish.
Right. Okay. Well, on that note, Jay, just kind of building on what Tom just said. So the future, then, you kind of think about, well, maybe we don't need these big, gigantic, high-power transmitters that we've always had traditionally in a broadcast plant if we move to an SFN model. Does that really mean that the future transmission facilities are what we would term today low-power TV transmitters and deployed in an SFN architecture? What's your view of the future there?
Well, I think SFN is definitely a groundbreaking technology and it's got so much potential. So if we step back a little bit, I think the broadcasters need to look at the business value proposition, the new revenue models that is going to be generated, and also how ATSC and 5G technologies are going to be interrelated. Now, the beauty of SFN is that it's going to be, it shares the same type of architecture with a 5G edge network, right? So there's going to be a lot of new business opportunities as a result of delivering apps, data, etc. from the edge. So what I feel is that we should start to look at SFN right from the get-go. I mean, from a high-power transmitter, you're going to get a big oomph, you're going to get that coverage, but it's absolutely essential to have an SFN strategy looking at all the business values and the opportunities that you can leverage out of that.
Okay, great. Thanks, Jay. Graziano, you brought this up before. I'm gonna skip over Joe for just a second, but you mentioned vertical polarization as a consideration stations should think about. Is vertical polarization, or at least elliptical polarization, a requirement for doing ATSC3? What's the thought process a station should consider when considering adding vertical radiation to their existing antenna patterns?
So just to follow up on the SFN, another consideration is that I just want to share with the crowd here is really considering capex versus opex. We're coming out of the repack with this big investment on the big stick transmitter. Natural evolution is probably going to be gap filler, but maybe if you're starting from a blank sheet with an out of repack station that needs to go 3.0, then an SFN with medium power might be a different strategy, and on the OPEX you're definitely going to have some saving. Back to the vertical polarization question, what we see and what we hear from Europe as a worldwide SFN implementation rollout we have done over the years is that what we actually have on the mobile device, if that's the main goal, reaching mobile, we have the fractal antenna on the receiving side. What that means is that your device doesn't really care if it's like this or like this, has to be able to receive anyway. Been saying that it will definitely provide more coverage, but the benefit really has to be studied. So with this test that has been going on around the world and here in the US, it's definitely good to see drive tests and to see the benefit of it. But it's definitely something to talk very, very true with your antenna manufacturer and see the benefit that this will bring to your business case.
Right. Okay, that makes sense. So, Joe, one of the often talked about things in broadcast circles is kind of the dearth of engineering talent, specifically on the RF side. There's just not a lot of RF folks left, and a lot of stations are looking to sort of recruit RF engineers and bring them in and try to train them and bring them up to speed. But one of the concerns is obviously is that ATSC3 is really a completely different paradigm in a lot of cases. So the existing staff may not have the skills to deploy ATSC3 as easily or as readily. What, from your perspective and what you've seen in some of the deployments you've been involved in, what's the real core skill set that an engineer at a station, let's say, really needs to have in their back pocket to be able to work on ATSC3 equipment, understand how it works, set it up? What are the skill sets that we're really looking for ATSC3 station engineers?
Well, I think that for a number of years now we've heard that we can't hire anybody unless they're an IT engineer, quote unquote. So don't mean to generalize too much, but that's certainly a sentiment. And with the ATSC3 standard being highly IP from its very front end out till it reaches the transmitter, it bodes well for that IT engineer at the station. So I think what you need, though, is that you need a IT person very familiar with IT and IP technology, but also has a little bit of a creative or outside of that interest and can digest some of the code rates. A little bit of signal processing knowledge along with the IT stuff goes a long way, because the transmitters and RF are simpler than ever, so to speak. We've tried as much as possible to make them module swap, power supply swap, like they would do in a server room. Take this blade out, put this blade in, take this power supply out, put this power supply in, if there's that type of failure mechanism. So the IT skill set's going to be very important for 3.0, and I think they can learn what they need to learn on the RF side, signal processing side, getting their hands on it.
Right. Yeah. I'm just speaking from my own personal experience. If you're not a networking guy, you're going to be lost immediately when you start deploying an ATSC3 station. So you really have to hone your networking skills, and that's something that us old RF guys are having a hard time doing. Tom, yesterday I mentioned there was an announcement here in this very booth about deployment in the top 40 markets. And the question comes up, are vendors going to be able to deliver equipment to meet that demand as well as the repack at the same time? Both new deployments and repack deployments simultaneously. Do you see any issues on the vendor side of sort of meeting that 2020 deployment that stations are looking for? Is there any bottlenecks in the equipment supply chain that we need to think about?
If we're talking about the ATSC3 equipment, like the rack over to my left, that stuff, it's kind of added as an aside to the repack, so I don't foresee there being a problem with deliveries. In terms of parts for upgrading existing transmitters, I mean, certain parts are going to be on a case-by-case basis. Other things like exciter swaps, we're getting those in all the time for the repack, so being able to supply those, put those together with kits for ATSC3, I don't see to be a problem.
Okay, thanks, Tom. So Jay, the ATSC3 standard just has a plethora of tools that we can use, various modes that we can operate in to accomplish different use cases and different use scenarios. From your perspective, is there any tools or any specific scenarios or use cases that really you think ATSC3 is going to do well, and stations should really consider doing this, like layer division multiplexing or any of the other things that are in their standard? Are there any of those that really stand out to you?
Yeah, so just going back to the earlier question about what new skills are needed, right, ties into this question. Truth be told, this ATSC 3.0 is really a broadcast protocol living in an IP world, right? So and also, because this is a hybrid broadcast broadband, the type of skills within IP that is really needed is people that understand the streaming technology extremely well, right? Because a lot of the concepts from streaming technology is now being used within this broadcast chain. So take, for example, the dash packager, right? That is a very complicated format. And so you really need to understand the different elements that go into that and how it packages. As a simple example, if you wanted to do an add insertion, it's not quite straightforward to know how you just even go about doing that without really having somebody that can pull apart the format specs. So back to what kind of features you need. As an example, scalable HVC is something that people get excited about. To say, oh, can we use that so that we could cater to people with low bitrate availability and as well as high bitrate. But there's so many encoding options that my suggestion is that just stick to the very basic ones and make it work. Right? So I think something like an HEVC is just plenty sufficient to get started.
Sure, absolutely. Well, and I think stations will gain experience and as they go along, and they'll figure out how to optimize those settings. Sure, go ahead, Tom.
The other thing to keep in mind with the IP-centric nature of ATSC3 is most of the stations already have news apps. They already have the equivalent piece of the news app on their website. So the development that you've gone through for the OTT is going to be very similar to or just additive for the development for ATSC3. So, you know, you get your encoding platform. It's going to have your OTT outputs. Probably one of those output bit rates is going to be 1080p, or could be 1080p, or even higher if you wanted to. But you know, who really wants to go past 1080p 60 when all you need to do is have that back channel link to UHD, and the TV is supposed to do it for you, or the home gateway. So really, a lot of the development that you're going to need to do for ATSC3, in some way you may already be farther than you thought. The limit may end up being that you don't have IP on your STL link up the mountain, and you need to change that out. Anyways, that's all.
Yeah, okay, great. So Joe, a little bit of a curveball question, so I'll just throw that out to start with. But it seems that today modern transmitters, the deployment of Doherty-designed amplifiers is a pretty common architecture that a lot of transmitter manufacturers are using. Is there any particular benefit to the Doherty design and implementation, specifically regarding 3.0 and the deployment of ATSC3? Is there a performance benefit that type of an amplifier gives us in the field, or was there any real motivation behind that? Is it just efficiency? What's the story behind Doherty and how that really marries with ATSC3?
Well, the primary benefit of the Doherty technology is increased efficiency. So, you know, we were all heading in that direction irregardless of ATSC3. However, one of the newest devices has what they call an asymmetrical Doherty capability that essentially increased the peaking amplifier half of that transistor. And the idea there was to increase efficiency of the overall system. But, you know, we get the ability of an additional peak capability, but it's not so important as it was just to get the efficiency up, because you know we've almost doubled efficiency going to Doherty technology. And you know, Doherty technology has been around since 1930s, and it's just highly nonlinear. As I say, nonlinear at any speed. So why did it take us so long to get here? Well, we had to go digital, you know, so that we could then correct for this high nonlinearity, because it would never work for NTSC.
Okay, great. So Graziano, just picking up on what Joe said, I know efficiency is one of the main things that broadcasters are looking at new transmitters, regardless of whether it's a repack or a 3.0 conversion. But maybe you could just sort of walk us through what efficiency really means to broadcasters in terms of reduced operating costs. What kind of percentage would a broadcaster expect to save if they're, say, replacing an old regular IoT transmitter with a new high efficiency Doherty solid state transmitter? What does that look like from a station's financial perspective?
Yeah, the efficiencies can mean different things. Definitely the power efficiency, what Joe was saying, based on the Doherty technology, is a big improvement. Based on the old solid state, or even like an IoT with YouTube, there's definitely a big jump of it. So even if you increase the power because you're going vertical, you can still see some saving. But it's not just that. You have more efficiency on the real estate. The size of the transmitter, the power density has gone up. You have more efficiency on the maintenance cost. So your OPEX per year in maintaining a transmitter, solid state, are definitely lower than an IoT. And it all goes in that direction. Even the spare parts, tube replacement, and so forth. So efficiency is definitely playing a factor in designing the new transmitter generation we now have. And it's definitely being a big benefit for the operator.
Okay, great. So, Tom, another little bit of a curveball here. You know, I know that your company is recently working on some VHF products, and I often get the question: Is it possible to do ATSC3 on sort of high band V, for example? Is that a workable scenario? You have any thoughts or perspectives about the VHF band and ATSC3, and what does that really mean to a station?
So yes, we're actually selling VHF band 1 Band 3, as well as UHF versions of our parallax transmitter now. We just installed the first channel 2 last weekend. Beyond that, I know that I remember hearing a lot about problems with ATSC 1 and low band V. From talking to people, we don't feel like it's going to be the same kind of problem, but to be honest, I haven't done a lot of testing on it yet. It's so at this point, I guess it's mostly folklore.
Right. Well, it's still an open question. I think a lot of people are interested in what does that really mean. Is an ATSC conversion market, is the VHF only good for the ATSC 1 host, or can it be considered for an ATSC 3 host? Those are still some unanswered questions, I think, but certainly questions that the industry is trying to grapple with at this point. So Jay, what's sort of your big takeaway? If our audience here in our group were to think about what's the one main thing that they should think about in terms of contemplating, building out their ATSC 3 station, what would you say is the one big takeaway for that?
Well, the one big takeaway is do not wait. Start now, because there's economic incentives in starting now, and why waste something that's handed to you? And then there is the business incentive, because there's so many new value propositions with ATSC 3.0, and you don't want to miss the bandwagon when people around you are implementing it. In fact, you can implement it for less cost now because all the technology is readily available. We're borrowing from enterprise IT and streaming. So we know what needs to be done. So why not start now? That's the big takeaway.
That's the big takeaway. Okay, great. I know we've got about 5 minutes left, so if anyone in the audience has a question that's just burning a hole in your pocket that you'd like to have answered, fire away. So go ahead, Kevin.
Any considerations for STLs for your plant?
Right. Okay. So Kevin's question is STLs, and what does that really look like in an ATSC3 deployment? Joe, you have thoughts about STL, and I know you've been a little bit involved in that in the standards process.
Yeah. The primary concern is you need to move to an IP-based STL, and then one experience I had with putting Pearl Phoenix on the air early was we were on the air, then we were off the air, we're on the air, off the air, what's going on here? And up at the transmitter site, there were packet collisions and so on. Somebody down at the studio side had, put some traffic in on our VLAN that was supposed to be dedicated up there for the payload traffic, and so there needs to be like a missile launch cover on that IP port saying do not touch, and if you don't know what this is, that means you, because while it's just IP, it's now the cash register. So get with you have the opportunity through repack or whatever to upgrade that STL to an IP-based STL. Look at the bandwidth it'll carry and ability to put appropriate VLAN and firewall it off, because it's going to become the cash register, as well as on the other side of that firewall, being able to do transmitter control and that kind of a thing. So just be very, very careful that you don't crisscross those networks.
Excellent. All right. Yes, sir. Your question.
Want to find out how far behind the television manufacturers are on this ATSC. In other words, when the local Joe Smith wants to go to Walmart to buy a TV, high definition TV now, he's not getting one that's ATSC 3.0. And so how far behind the curve are the manufacturers in getting those out to the retailers so that everybody can have them?
Sure, I'll take a shot at that. The Pearl Group, who's a client of mine, has been working very closely with consumer electronic manufacturers, the typical names that you would think about. And the target for those CE manufacturers is to have product for CES 2020. So you'll see product in January in the show here in Las Vegas. And it's usually a 6 to 12 month ramp up from being on the show floor to being on the shelf at Walmart. So I would anticipate by fall of 2020, early 2021, we'll have product nationwide in retailers. That would be my expectation. Other questions? I
think your question assumes that we have to be completely dependent on the CE manufacturers for the for the TVs to have the tuner in it. But I think there's a different reality out there. There are a lot of companies working on dongle set-top boxes that could make any display device be a ATSC TV consumption device. So
Right.
I think that problem used to be a big problem, but I don't think it's a issue anymore, in my opinion.
That's a good point. And there are other products that are contemplated, like an ATSC3 gateway, which you probably have seen from NAB in the Futures Park area here at the show. So as Jay points out, there are a lot of other things other than just television sets that can be ATSC3 receivers. Any other questions from the audience? We've answered every single question that you have about building your ATSC3 station, and I have to say, I'm pretty darn proud that we were able to do that in 30, 40 minutes. So, any other closing thoughts from any of our panelists about consideration? Sure, Joe.
Yeah, sure. I just want to address that too. Is like I think in the original DTV transition phase, we needed TV sets. That was obvious. In this phase, it's not the same thing anymore. For TV for mobile consumption, otherwise in the home consumption, in vehicle consumption, and it's not just television. Let's consider this as data. It's just the data we tend to think that we're hauling is video or television, but it can be used for a lot of other things. So if we go forward into this transition thinking television, we'll fall short. So that's where I think the work that the pilot is doing on a home gateway, people are doing for in-car reception and other applications of the ATSC3 technology is paramount to really being successful.
From me, I like to live on a high note with some excitement. So what's really exciting among many things on the ATSC3 standard, I see the LDM as a layer division multiplexer as a big opportunity. That's what broadcasters in the US are. They are local to their community, they are true to the community, and they have the possibility to, on their DMA, to customize local advertising or local data casts, for example. That's really an exciting opportunity. And last but not least, keep in mind that, again, we have to serve the community the best we can, and do that as an engineer, meaning focus probably on the coverage, make sure your signal is strong, people can receive your signal, and maybe with the trade-off with the bandwidth, with all the modulation options you have out there, I would put first and foremost the coverage penetration of your signal.
Great, awesome. All right, Tom, closing thoughts, suggestions?
If you're moving forward with an existing transmitter, have an honest assessment of where you are and where your physical plant is. If you have a more modern transmitter, then you need to look to your IT network. As Joe said, it's not just packets. Every Ethernet packet is currently 7 MPEG packets. So when you lose one data packet, you're losing. If it's an audio packet, you're going blank. So as you move more to IP, you need to keep those things separate. Keep the business network away from the video network. It really will be key to making your life easier.
Great. All right, Jay, closing thoughts?
So, we're used to thinking television as live linear, but now with ATSC 3.0, I think it's very different. We can start to look at TV as a VOD delivery. So I think we should seriously look at the synergies between 5G and ATSC, because it's going to open up so many new business opportunities for us. Just VOD is just one such example. I think there's so many other examples that there in the ATSC guide. But really speaking, I think we got to put on our business hats and look at the new business opportunities opened up, not just with the new transmission capability, but just the overall ATSC picture.
Yeah, I think, the takeaway for me to this group is that ATSC3 is really a fundamental change in our core business. We've made our living for the last 40 years in this business selling 30-second ads to Ford dealers. A lot of people have heard me say that before. And this system really gives us the capability to do other businesses rather than just selling ads to Ford dealers in our local markets. And it's really exciting, I think, from our business perspective, to think about what the potential is for broadcasters to take advantage of that. So let's thank our panelists. Thank you very much for coming, and hope you have a great show. And please make sure you visit the ATSC3 vendors that are on the floor here at the NAB show. Thank you so much.